I feel so privileged to be working at a time when we are learning how to recognize human talent for the science and technology workforce needs that we have now and that we're going to have more and more. It fills me with a very human kind of hope that we really will be able to tackle and solve big challenges that only scientists and engineers and technologists can solve.
This is the Discovery Files podcast from the U.S. National Science Foundation. I'm Nate Potker. The future of the science, technology, engineering, and mathematics enterprise will require input from all sorts of unique individuals to achieve its utmost potential. Innovation and the makeup of the STEM workforce will come from individuals representing a wide variety of neurocognitive perspectives. We're joined by Keivan Stassun, the Stevenson Chair in Physics and Astronomy at Vanderbilt University, where he also serves as director of the Frist Center for Autism and Innovation. His work advocating for diversity in STEM was recently acknowledged with a Genius Grant, the MacArthur Fellowship. Professor Stassun, thank you for joining us today.
My pleasure. Thank you for having me.
I'd like to start with a little bit of background, and I want to ask you, when or how did you know you wanted to be an astronomer?
Oh, gosh. Well, the honest answer is that all through high school, I was obsessed with the idea of becoming an astronaut. And I learned that, at least at that time, the best chance I would have for joining the astronaut corps would be to become a military pilot. And so I went through the process of getting myself admitted to the Naval Academy, and I even attended for the first summer for basic training and plebe summer, they call it. Decided after that a military career wasn't the path that I was going to want. And so I went to University of California, Berkeley instead, and I found myself there asking, so if I'm not going to go up into space, what am I going to do instead? I decided that studying the stars would be the next best thing, and I don't regret it.
Keeping on the astronomy theme to begin here, what keeps you excited about working in the field? Like, is it the sense of discovery, the endless possibilities that are out there?
I mean, I think that's probably true of every scientist or engineer. There's that sense of, all the things we don't yet know that's out there to discover. With astronomy specifically, I wake up every morning literally excited about the possibility of discovering some new Earth out there that might be habitable, might even be inhabited, and that is tremendously exciting to me. The idea that within my own lifetime, we may come to know of another place out there that is like our own planetary home, and where we may yet discover the signs of other life, maybe even a place that we could imagine people here eventually going there. We are living in a time where science fiction is becoming more and more science fact, and that specifically is very exciting to me.
Awesome. So thinking about your work, is there any particular discovery that you're proud of or that you feel like is your favorite to share with people?
Oh, yeah, actually there is. I'm proud of a lot of the work that I and my research team have done over the years. But there is one that in my mind just brings together so much about unexpected discovery on the one hand, involving talented students from different backgrounds and different abilities and perspectives on the other hand, all in one. So some years ago, about 10 years ago now, my research team and I were working with data from NASA's Kepler spacecraft, which was collecting data on lots and lots of stars in our galaxy to look for planets orbiting those stars. It was an exoplanet hunting mission, and I had in my research group at that time an autistic student in computer science at Vanderbilt. I also had an African American student who had joined my lab through a partnership program that I helped create with Fisk University together with Vanderbilt here in Nashville. And the autistic student working in my group developed a new way of analyzing the Kepler telescope data, literally turning the light signals that the telescope collected into sound, sort of sonifying the data, which gave us a new way of just sort of, quote unquote, looking at the data and understanding it. And with that tool that he invented, my PhD student was able to make a completely unexpected discovery, which is that it turns out we can accurately determine the sizes and ages of stars just on the basis of what we came to call light flickering or sound flickering in the star's data. This had not been known before, and we published this in the journal Nature. In the process, the student who led that work became the first African American woman ever to lead an astrophysics paper in Nature, and the data analysis tool that my autistic student had developed became licensed by NASA for use in their data analysis work. So you see what I mean? Just unexpected discovery, involvement of talented students with lots of different abilities and backgrounds and perspectives all in one. That meant a lot to me.
So that kind of leads into the next area I wanted to ask you about, and that's thinking about neurodiversity in science. Can you talk a little bit about how you became interested in that, and maybe for the general public that's not thinking about it, why it's important?
My own journey in this direction began from a very personal place. My firstborn son is autistic, was diagnosed with autism when he was 4 or 5 years old. For several years thereafter, again, just in my personal life, that experience as a parent was shaped entirely by trying to figure out how to support my son and, what he needed. So, early interventions and supports and helping him be ready for the world of school and sort of all of that early little kid stuff, which is so important. But eventually, I began to think about his own future and, what his experience would be like in life as an adult, and beginning to see alongside his support needs, which will be there, forever, beginning to see real unique abilities, a way that he had of sort of seeing the world, of recognizing patterns and things, noticing things that most people would miss. And I began to wonder if there was an opportunity for the world to benefit from these unique abilities that I was able to see as his father. Could the world, right, learn how to better recognize and enlist these abilities at the same time that we are learning to better support people like him? And so that inspired me to begin intentionally recruiting autistic students at Vanderbilt into my research group, which gave me an opportunity to learn how to manage a neurodiverse team, and beyond a diverse team, a neurodiverse team in particular, which meant not only for me as a supervisor and advisor and manager, learning how to work with more and different kinds of people, but also helping everyone on my team understand how to interact with one another so that everyone was enabling and enlisting the best of each other, right? So that was a real learning opportunity for me, but also, had the opportunity to witness firsthand how real, unique, and impactful scientific discoveries are enabled when we recognize and enlist and support all different kinds of minds, right? There's a human diversity of mind that we need to fully leverage if we're going to have the best chance of tackling the grand challenges that we face as a society.
As part of this journey for you, you started the Frist Center for Autism and Innovation. Can you talk a little bit about that center itself?
Yes. So about 6 years ago now, together with colleagues in the School of Engineering and the Business School here at Vanderbilt, we launched this academic research center called the Frist Center for Autism and Innovation, named after a philanthropic family that generously helped to endow the center. And in looking at where we could make the most sort of value add to the world of autism research and related work, what we saw is that, right, for decades there has been a large amount of investment and development of expertise and programs and interventions, largely around early years, early diagnosis, early interventions, clinical approaches and supports, all of which it has been hugely important. Where there has been much less investment and development of expertise and programs and supports and interventions is around transitions to adulthood and transitions to independence and transitions into the workforce, including in particular the STEM workforce. And so we launched the Frist Center for Autism and Innovation in the School of Engineering and in collaboration with the Business School, with the idea that we can bring engineering and hard science to bear on developing technologies that support individuals in making those transitions to adulthood and independence and access to meaningful employment. And at the same time, we can be working to build real pipelines to employment, in part through better equipping individuals to be successful in accessing work, but also working with employers, including specifically companies and other employers who are seeking STEM talent, right, for the STEM workforce. That's where we wanted the Frist Center for Autism and Innovation to be operating. Technology development and transforming the workplace inspired by that human diversity of mind, and enabling access for individuals and enabling access for those who seek to employ those talented individuals.
One of the specific programs I know has been very successful there I wanted to ask you about, and it's the Frist Center's PhD program in neurodiversity-inspired science and engineering. Can you tell us a little bit about the success of that program?
I want to clearly acknowledge and thank the National Science Foundation for the NSF Research Traineeship grants, the NRT grant that we received to help create this interdisciplinary PhD program, develop a set of graduate seminar courses to support it, and of course the ability that grant gave us to recruit students, support them with stipends and all the rest. But the Neurodiversity Inspired Science and Engineering, or NICE, program was developed with the idea that, especially but not only for neurodivergent students in science and engineering, having an interdisciplinary PhD program that would support them in their journey toward a PhD in coming up with ideas, inventions, technologies, scientific approaches and algorithms, all the kinds of things that PhD students do in the course of their doctoral training, but to invite students to be thinking creatively about those things, research projects, dissertation projects, that would intentionally include their neurodiverse perspectives. We believed, and it has been borne out after 5 years of running the program, that we would be able to better recruit neurodiverse students, better support them, and have better outcomes in terms of their own PhD completion, but also just the great discoveries and innovations that they would create along the way. For example, we have had PhD students who have designed virtual reality platforms that teach autistic adults how to engage in social communication that will allow them to be more successful in gaining employment and being successful on the job. We have had PhD students who have created, this has nothing to do with autism per se, but bringing their creative perspective, have designed and patented detectors for mining a rare earth material from asteroids. We have an autistic woman who is finishing her PhD now in biophysics, who, based on her own lived experience, has designed and is commercializing an ear implant that will allow individuals to fine-tune their auditory experience if they have auditory sensitivities that can create challenges for them as they move through the world, much more intelligently than a simple noise-canceling headset. By inviting that creativity and that inventiveness that springs from one's own lived experience, right, we're seeing tremendous outcomes. As just one more example, we have an autistic man in our neuroscience PhD program who's participating in our NICE program, NRT program, who, when he completes his PhD in neuroscience in a couple of years, he will, to our knowledge, become the world's first nonverbal autistic neuroscientist. Think about that, right?
That's fantastic.
These are outcomes and opportunities that are now possible because of the advent of technologies that we didn't have available to us even 10 years ago. These folks are changing the world, changing how we understand the very nature of the human mind, right? Because they are now able to bring and communicate and express and share their unique perspectives and their inventiveness and creativity.
This work has been acknowledged in a big way this year. You got the MacArthur Fellowship. Can you talk a little bit about your experience getting the Genius Grant? What was that like? What does that mean to you?
Well, I mean, first of all, just what an honor. And it's the kind of thing that I think, you can't expect. I mean, it's not something you apply for, and it's such an outrageous recognition that I certainly never imagined it coming. It was very unexpected and just a tremendous surprise, but a great honor. It gave me an opportunity to talk about this work that we've been discussing, and to talk about it in the terms that the MacArthur Fellowship is intended for, which is about creativity, sort of creative genius. And I don't mean to apply that to myself necessarily, but rather that, the work that I do as an astrophysicist, but also as a developer of STEM talent, is really very much inspired by the idea that creative genius is out there, and oftentimes in unexpected forms, or in ways that we in the past have not understood how to recognize. I think of that actually as sort of my life's work beyond my legacy as a scientist and the scientific discoveries that I'm a part of. It's learning how to recognize and enlist human talent for scientific discovery in new ways, recognizing creative genius in new ways and new forms. That's so the MacArthur sort of gave me an opportunity to speak to that work of which I'm, that I find so meaningful, and to speak to it in those terms. I think that was important.
What difference has NSF support made for you?
At every stage and at every turn in my career, NSF support has been the enabler, has been the fuel, has been the accelerant. As a graduate student, I received a graduate research fellowship from NSF that gave me a recognition and an imprimatur, but also a certain amount of independence to be able to shape my own PhD experience in ways that I might not have otherwise been able to, including as a graduate student undertaking some professional and leadership development activities that would later position me to be able to, for example, create the partnership program between Vanderbilt and Fisk that has become one of the top producers of PhDs to underrepresented minorities and neurodiverse people in the physical sciences. The ability that I had to develop that work as a part of my NSF career grant supported early career work was very much enabled by NSF support of me as a PhD student to begin learning those leadership development skills. And then later, the NSF PAIR grant that we received to really build out and scale up and institutionalize the Fisk-Vanderbilt Partnership Program was critical for taking what was initially an individual PI project, but really scale it up and institutionalize it into what it has now become. All the way to now, the active NSF Research Traineeship Grant that has allowed us to create and operate the Neurodiversity Inspired Science and Engineering PhD program. These have been NSF supports to me as an individual, but even more important to the sort of the institutionalization and scale up and model development kind of work that has enabled not just the support of me as an individual scientist, but the creation and dissemination of model programs that touch lots and lots of lives. It has all been enabled and fueled and accelerated by NSF support.
What do you see in the future? What makes you optimistic about what's coming up in the next few years?
On the astrophysics front, I am excited. Literally every morning I wake up and I am just filled with excitement about the discoveries that I know are right on our horizon around habitable worlds, signs of life elsewhere in the universe. I mean, these are real discoveries that are waiting to be made, and they feel like they're right around the corner. And to have a front row seat and to be actively involved, to have my fingers literally in the data that we're collecting to make those discoveries is, it feels like I'm a kid in a candy shop with that. And at the same time, I feel so privileged to be working at a time when we are learning how to recognize human talent for the science and technology workforce needs that we're going to have, that we have now and that we're going to have more and more through this century. Learning how to recognize human talent in new ways where we didn't know how to recognize talent in the past, that human diversity of mind that we need, and learning how to recognize and support it. That excites me too. It fills me with a very human kind of hope that we really will be able to tackle and solve big challenges that only scientists and engineers and technologists can solve. There is a depth and a breadth to the talent that exists in the diversity of human mind that is available to us, and we're learning how to recognize and tap into it.
Special thanks to Keivan Stassun. For the Discovery Files, I'm Nate Podker. Please subscribe wherever you get podcasts, and if you like our program, share with a friend and consider leaving a review. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.